Sorry about that. My sub was calling, so I needed to answer it. So if I multiply by square root of x and square root of x on the top, this is going to give me 7 square root of 2x because I can't do anything. And the 7's on the outside of the radical, and the root 2x is on the inside. So 7 stays on the outside, 2x stays in the inside. Underneath the radical, we now have 2x and 2x. And so when we look for a pair, we have a pair of 2's and a pair of x's. So this is going to give me 7 square root of 2x all over 2x. So notice how it just makes the radical sign go away. So hopefully you start seeing that pattern so that, again, as we break this down as a root on top and a root on the bottom, if I multiply the top and bottom by square root of 3, both of these are under the radical, which means I can multiply them together, and they're both prime, so I can't pull out anything. So this is going to say 6y squared. And then because they're both root 3, I just write down 3. And this is my answer. So again, as we get more and more used to it, hopefully you're noticing that we just get the bottom, whatever is underneath the radical sign every single time. When I look at this one, we're going to do cubed root of 32. You can do this a couple different ways, actually. If I wanted to simplify first, if I look at cube root of 32, this is the same thing as 4 times 8. And this is 2 times 2. 8 is 2 times 4. This is 2 times 2. So as I look at that, this can be rewritten as, again, we're looking for 3 of a kind because there's 3 on the shelf or the index. So you've got 3 2's. So a 2 is going to come on the outside. And then you need 3, and this is 2 times 2. So notice as I look at that, I need one more 2 in order for me to be able to pull out 3 of them. And so if I do cubed root of a 2 here and a cubed root of a 2 here, that gives me 3 on the bottom. And so this ends up being 5 cubed root of 2. And then on the bottom, you get 2 from here. And now you've got the cubed root of 2 times 2 times 2, which makes it so I can pull out a group. So I've got 3 of 3 2's that get to come out. And so then my final answer is going to be 5 cubed root of 2 over 4. And this would be my answer. When you look at number 7, because it is a root 5, we're going, or root 5 minus 2, it's 2 terms. I'm going to multiply by the conjugate, which is root 5 plus 2 on the top and on the bottom. And so when I do root 5 plus 2, root 5 plus 2, I can distribute or multiply the root 13 by everything. So what happens is this makes it so it's root 13 times 5 plus 2 times root 13. And then on the bottom, again, if we go back and we do the box, that's fine. But what happens is it just makes it so we get rid of the radical sign. And so we get 5. And then it's always going to have, well, maybe we better make sure we're good with that. I'm just going to do it and then erase it. But when you do the box, notice how, I want you guys to notice what happens. Like what happens in the, this is minus 2. What happens in the box? So root 5 times root 5 is root 25. Root 5 times 2 is 2 root 5. Negative 2 root 5 is negative 2 root 5. And negative 2 times 2 is negative 4. And what I want you to notice is, notice how if I'm looking at the radical or the diagonals and I'm adding, the square root of 25 simplifies. The square root of 25 is the same thing as a 5. So I'm going to go 5 plus negative 4, which is 1. And then you've got negative 2 root 5 plus positive 2 root 5 makes those go away. And so what happens is I just get a 1 on the bottom. And so my answer ends up being the square root of 13 times 5. So that's going to be 65 plus 2 root 13. And because there's a 1 on the bottom, I don't need to worry about it. Okay, but that's really handy. If you can do the box, it helps you see what you're going to get instead of trying to remember a rule. The rule's nice because you're just going to square the first term. So square root of 5 squared is just 5. And you square the last term, which is 4. And 5 minus 4 is 1. So it works out nice, but you just want to be careful. Make sure you're okay with the whole idea. Same thing here. We're going to multiply by root 2 minus root 7 because that's the conjugate. Root 2 minus root 7 because that's the conjugate. And then we're going to distribute the 12 to both pieces. So this is going to be 12 root 2 minus 12 root 7. And then on the bottom, as we do that box again, let's look and see. We've got root 2, root 7, and root 2 and negative root 7. So as I multiply, root 2 times root 2 is root 4. Root 2 times root 7 is root 14. Negative root 7 and root 2 is negative root 14. And negative root 7 times negative root 7 is negative root 49. Or 7 times 7. If we want to write that as just what times what gives us that, the same thing with 4. If we want to leave it in factored form, so 2 times 2, sometimes that helps you see that you've got a pair of 2, so this box is worth 2. You have a pair of 7, so this box is worth negative 7. And then when you look at what goes diagonal, so these 2 and these 2, and we're adding 2 plus negative 7 is negative 5, and negative root 14 and positive root 14 goes away. And so this would be my answer. Hopefully that works. If you're having a hard time with that, make sure you ask for some help. When you look at solving the real life problems, it's kind of the same thing. They just want you to see if you can go further. So it's talking about the distance that you can see to the horizon with your eye level. And it says it's given by that equation. So D is equal to the square root of 3h over 2. And it wants you to see how far can she see when your eye level is 5. And so h is your eye level. And so they're just having you plug that in. So this would be the square root of 3 times 5 divided by 2. And so you're just going to put that in your calculator. So square root of 15 over 2, or the square root of, or you could just do the square root of 7.5. Either one of those would be fine. And you just put it in your calculator the same way as you normally would. So square root of 7.5 would probably be the easiest. Once you divide it, it's already a nice clean decimal. And so this would be 2 point, and it will tell you what place value to change it to. So we're going to do, actually it doesn't tell us, but we're going to just guess 10th place. So 2.7 miles is how far you can see if you're 5 feet above the water. And then when you look at example 7, it talks about the golden rectangle is 1 plus root 5 to 2. So they want you to write that as a ratio first, so or a proportion. So you're going to go 1 plus root 5 over 2 would be one way, or you could write it as, that's probably fine. So it just says, think of the length and height of the Parthenon as the length and width of a golden rectangle. And so if we look at your whole, your picture over to the side, they're saying that this h to 31, so this would equal the same thing as, I just want to length, so it's length to width. Okay, so length to width. So this is the length and this is the width. And so when I look at that as 1 root 5, the length is going to be 31 and the height is going to be, or the width is going to be h. And so when you do the cross product, you've got h times 1 plus root 5 is equal to 2 times 31, which is 62. And then we're going to divide both sides by 1 plus root 5. And that cancels out. And then we're going to just solve. So 62 divided by 1 plus root 5. We can just put that in our calculator and get an approximate. So this won't be exact. This will be an approximation. So 62 divided by, and when you divide in your calculator, make sure you're putting parentheses around the 1 plus root 5. If you don't, you're not going to get the correct answer. So just be careful with that. And so, let's see. So that's going to give us about 19.2 if we were looking for 19.2 meters if we were looking for it as a decimal. All right, I think that's where we're going to stop for 4.1a. Make sure you ask for help if you need some or if you're not understanding something, and your assignment is on big ideas. So we'll talk to you later.